Yippee! Last video to be ready for Monday, August 17th. I only have 60 to 80 more to do for the semester, but I will. Anyway, so let's talk about factors. Is 3 a factor of 15? Yes or no? Is 4 a factor of 10? Yes or no? Hopefully you know the answer is yes, and you know the answer is no for this, but why? It's because if you take 15 divided by 3, you get an answer with no remainder. Whereas if you take 10 divided by 4, you end up with 2, and you have a remainder of 2, so you get this fraction part, or you get this remainder of 2 part. So 4 is not considered to be a factor because you get a remainder that's something other than 0. So what do I do to check to see if x plus 2 is a factor of this or not? I need to do synthetic division, because if I get a remainder of 0, then I know it's a factor. So you should be experts now finally at synthetic division. So I'll bring the 1 down, multiply here, get a negative 2, add those, get a negative 5. Multiply the negative 2 and the negative 5, get a 10, add those and get a 7. Multiply negative 2 times 7, I get a negative 14, and add those, I get a negative 3. Multiply a negative 2 times a negative 3, I get a 6, and I get a remainder of 0. So this right here is my remainder. So what's my conclusion? Yes, because that remainder is 0, x plus 2 is a factor. Now, you don't have to do this step if I asked you, but what is going to be the resulting expression if you factor an x plus 2 out of that polynomial? Well, it's going to be x plus 2 times the depressed polynomial, which would be x to the third, minus 5x squared plus 7x minus 3. And that's what you have, and if you had to, you could check to see if it had other factors, but that's not what my goal is. Because the remainder is 0, it is a factor. That's the factor theorem. All right, counting to 5. Oh, I have another one for us to do. 1, negative 6, 2, 12, 30. A nice straight line. Get a 1 here, multiply, get a 3. 3 times a negative 3 is a negative 9. Add those and get a negative 7. Negative 21, add those, and I get, let's see, that looks to me to be a negative 9. Multiply this by a negative 27, and I get a 3 left over. So is x minus 3 a factor? And the answer is no, because you got something other than a 0 for that. So not that you have to write this, but if you wanted to write the division, then if you divide by x minus 3, you're left with x to the third minus 3x squared minus 7x minus 9 with a remainder of 3. So that's just review synthetic division and what you'd write for that. But the only thing you're doing here is you've proven by showing me the division that this is not a factor. All right, hopefully you pause me. The remainder theorem. Well, I want to show you what happens if you do the other way and you just plug in f of a negative 3. Wherever you have an x, you put a negative 3 in place of it. You get a negative 27. This is a negative 63. This is a negative 12. This is a minus 5. So check my addition. I know you will. There's always somebody in class that does. Negative 90, negative 102, negative 107. So f of a negative 3 being equal to a negative 107, That's like saying you have the point of this function that's going to be negative 3 and 107. All right, I would like to show you synthetic division, which some people, if your name's not Dr. Lane, would be able to call synthetic substitution. I would put the negative 3 into there, and I would have 1, negative 7, 4, and negative 5. Bring the 1 down, multiply here, get a negative 3, add those together, that gives me a negative 10. Multiply those together and I get a 30. 4 times 30 is 120. Multiply the negative 3 times that, and I must have done something wrong somewhere. Otherwise, my whole idea just blew up in my face. So let's see, 1, negative 7, 4, negative 5. I plug things in correctly. Time to pause. Hopefully I don't do accident. All right, this is why I need you. I added wrong. This thing right here is not 120. That's where I screwed up. And so I need to erase the 120 and do the right thing, and I need to erase this while I'm at it. This added together is 34. Okay, and if I multiply negative 3 times 34, it's going to give me a negative 102, and my answer is a negative 107. Eureka, I have found it. So, guess what? This remainder right here is the same thing as what you'd get if you plugged in the negative 3 the other way. So the remainder theorem is simply saying that you can plug in a number into a function, and by doing synthetic division or substitution, you can get the same result. Okay, so even though I made the mistake on this part right here, it still beats the heck out of doing this up here, trust me. Okay, that's the remainder theorem. All right, let me pause here and make sure you've got everything you need. All right, the rational root theorem. If you have an equation like this, or if you have a polynomial function, if you want to find the answers to the equation or the zeros of the function, then you can identify possible rational roots by taking all the possibilities of P over Q. And when I say P, I'm talking about whatever this number is the values you put all the possibilities of factors for P, and Q is going to be whatever this number is. Okay, so I need to show you an example. And so here's going to be our example. I think I'd like to get some other colors in our life now. This is P. That's a terrible arrow. This is P. So I'm going to list all the factors of 6 that I can think of. 1 and 6, 2 and 3. So basically I like to just do, here's 1 and 6, 2 and 3, and I write them that way, and I leave room in between so I can put them in order. If I take all the factors of Q, let's put them in a different color. I'd take that 8, and I'd have plus or minus 1 and plus or minus 8 is what I was talking about on that other. Plus or minus 2 and plus or minus 4. All right, so if I want to list all the possible rational roots, I have to take every combination that I can think of the numerator over the denominator. And that's going to be the numbers, possible roots that are rational that will work. Anything else that's not one of these will not work. So I'm going to start here. And I'm going to put the 1 over everything that you see. 1 over 1, which really is just a 1. 1 over 2. 1 over 4. and 1 over 8. Then I'm going to put the 2 over 1. 2 over 2 we already did. 2 over 2 is a 1. 2 over 4 we already did. That's a 1/2. 2 over 8 we already did. That's a 1/4. So there's nothing new. However, with 3 over 1, 3 over 2, 3 over 4, and 3 over 8 are all possibilities. But I'm not done yet because I have to do the 6. 6 over 1 is a new one. 6 over 2 is a 3. 6 over 4 is a 3/2. And 6 over 8 is 3/4. So really there's nothing else new. And these are the only numbers that could possibly work. That's it. So if we were going to actually see about factoring this, we could go ahead and do that. And we're going to go ahead and try some in the next slide. But I need to erase because I cheated. I put the answers there. Oops. You're not supposed to know those. So I'm going to take that expression. Actually, I think I'm just going to copy the whole thing. And I'm going to paste it. I'll make it a lot smaller so I have more room to work here. All right, so when I start doing this, there's a couple ways to do it. I'll let you decide how you want to do it, but I'm going to go ahead and show you a way that's going to kind of make a table. And we're going to do synthetic division or substitution, whichever you want to call it. So this is my P over Q. My coefficients I write right here. And now that I've done that, I think I want to erase that and move this over. And let me erase a little bit more. And I put the -6 here. And this is just another way to write synthetic division, but you got to do more of it in your head. Now, there's some things about this that I could tell you about with Descartes' rule of signs and least upper bound, greatest lower bound. I've explained it in the next video that will help our search. But what I want to show you is I want to find all three of them, which you happen to see what the numbers were. But I want to find all three of them and show you that the answers that you get are going to be in this set that we've identified here and here. Okay, if it's going to work, it's going to be in that location. Looks like I got a stray mark there. I need to fix this. All right, so let's pretend I didn't see those things. So what we could try to do is, most of you'd say, let's put a 1 or a -1 or something like that. Most of you probably say a 1. I'm going to go ahead and do a -1 just to be different. You bring this number down, and then you multiply these two numbers together, and you need to add it to this number. So -1 times 8 is a -8. Add those together, and I will get a -2. -1 times a -2 is a 2. Add that to the -23, I get a -21. -1 times 21 is going to be a +21. Add that, and I get a 15. So, is x plus 1 a factor? And the answer is no. So I have to keep going. All right, so I could go in either direction, and again, like I said, there's some ways to restrict this that you'll see in the next video. I'll bring the 8 down, and I'll do the process in my head again. I take this number and this number, multiply it, get a -16, and add it to the 6. So I'm going to end up with a -10. And then I'm going to multiply the -2 times the -10, and I get a +20, and that's going to give me a -3. And -2 times the -3 is a 6, and I get a 0. So what does this mean in the big scheme of things? It means that x plus 2 times 8x squared minus 10x minus 3 is equal to 0 is our factors that we have so far. Okay, that's going to be this version up here that I've rewritten in its factored form with the depressed polynomial. Now, I don't really want to do the quadratic formula. I'm going to suck it up and factor this. And based upon the numbers, I know I should do 4x and an x. Now I just have to figure out what combination to use. I think I want to use a, excuse me, I need to fix that. That should be a 2x. And anyway, I think I know what I'm supposed to do. This needs to be a -3, and this is supposed to be a 1. If you check the O and the I part of FOIL, this is a negative, oops, you can't read that. This is a -12x. You do the inner part, these two. This is a 2x, can't read that. Or 2, I don't really care about that. So it adds up to a -10, which is what you see right here. So I have factored it correctly. That's checking the OI in FOIL. All right, so the answers then, as we could write them, would be x equals a negative. I don't know why I put a +4 there. I'm lost my mind. Like I said, this is why I need you sometimes. Not always, but sometimes. So this needs to be a 2. This needs to be erased. Anyway, we get a -2, a -1/4, and a +3/2. Look at that set of numbers, and look at that list. Here's the -2, here's a -1/4, and here's a 3/2. You have no other possible rational roots, and there they are. So 2/5 wouldn't work, 5/7 wouldn't work, 93/12 wouldn't work, or some number like that. All right, so this is the rational root theorem. Now, what you're going to have to do is find only one of these on the test, because basically I don't need to see all of this old work that you're doing right here. I don't need to see this old work to go from here to here. I just want to know, can you do this part of the process and find one? So that's what you'll have to do. All right, so we'll do more examples of that in our Zoom session, I'm sure. So what I'd like you to do for your knowledge check is I'd like you to tell me all the possible rational solutions. So when I see your work, you're going to have to show me P, Q, and P over Q. Those are the 3 things you're going to need to tell me with all of the possibilities. All right, counting to 5, and I'm done for August 17th. I'm ready.